Okay, so let us go through one more. What time is it? Okay, so we have two more examples. So let us go through. So in an exam, I could give you the entire array itself and ask you to count the number of inversions, or I will give you just two sorted subarrays and ask you to show the process of finding the inverted pairs just in merging these two sorted subarrays. So let us go through a scenario like that, and I'm recording the video for that, so this will help you to do this. Okay, so let us say you're given these two sorted subarrays and these are the index entries. So the first step, as you can also notice, is to identify the mid value. So if you're merging two specific sorted subarrays, the mid value is going to be fixed. So in this case it's 5. Okay, that's the definition or the process of identifying mid is it's the index of the first or the first index in the right subarray, which is 5. So start with I at 0, j is at 5. The corresponding data. So you have 14 and 13 here. So 14 is greater than 13. So that's an inversion. So you can write down S. And how many inverted pairs? Mid minus I. 5 inverted pairs. So 5 minus 0, that is 5. So 5 inverted pairs. So write down 13 in the sorted array. That's the smaller of the two, 14 and 13. And move the j to the next index, which is 6. So I stays at zeros, okay, and j is at 6. So what are those 5 inverted pairs? We saw that in the previous cases. We can write down that too. So 14 13 is an inverted pair, 17 13 is an inverted pair, 19 13 is an inverted pair, 22 13 is an inverted pair, 25 13 is also an inverted pair. So those are the inverted pairs we can find just based on this value of I and j, this particular value of I and j. So now we have I at 0, j is at 6. So 14 compared with 16, 14 is not greater than 16, so that's not an inversion. So simply write down 14, the smaller of the two, and move down the corresponding index. So we write down 14 and move I to the next index 1. So now compare index 1, we have 17, index 6, we have 16. 17 with 16, that's an inversion, 17 greater than 16. So how many inversions? Mid minus I. Mid is 5 minus I is 1, so 4 inversions. 5 minus 1, 4 inversions. And what are those inverted pairs? 17 with 16, it's an inverted pair. So even though I'm not showing here, you should be able to write down the inverted pairs too. Then 19 with 16, 22 with 16, 25 with 16, those are the 4 inverted pairs. So write down the smaller of the two, which is 16, and move the next index to the next element. So j is now at 7, I is at 1. So 17 compared with 18, 17 is not greater than 18, so there's no inversion. So write down 17 and move I to the next index. We have index 2. We have 19 and 18 here on the right side. So 19 and 18, that's an inverted pair. So how many inverted pairs? Mid minus I, so 5 minus 2, 3 inverted pairs. So that is 19, 18, 22, 18 and 25, 18. Those are the inverted pairs. So write down the smaller of the two, which is 18, and move j to the next index 8. So now 19 with 20, there's no inversion. So write down 19 and move I to the next index. 22 with 20, that's an inversion, 22 greater than 20. So the two inverted pairs based on the mid minus I, 5 minus 3 are 22, 20 and 25, 20. So write down the smaller of the two, which is 20, and move j to the next index, which is 9. So now I is at 3, 22 is not greater than 27, so no inversion. So write down 22 and move I to the next index. So 25 greater than 27, no. So simply write down 25 and you're done with this left subarray and just write the right subarray. So in this process you count the number of inversions using the mid minus I formula, which I should have stated somewhere here, mid minus I, but you can write down as part of the table too if you want to. Here. here. So this is mid minus I. That's the formula to count the number of inversions in each step. So it will add up to 14 in this case. So those are the number of inversions just in this merging step. Okay. So I have another example which you can go through as practice. So again, always once you are given the two subarrays, the mid is fixed. So in this case, it's again 5 in this example. So let me see how much time we have. So we'll go through it quickly. We went through it already a couple of times. So I is at 0, j is at 5. So compare 2 with 1. 2 greater than 1 is an inversion. How many inverted pairs? So I is 0, mid is 5. So 5 minus I, 0 is 5. So the 5 inverted pairs can be determined here. So 2 1, 3 1, 8 1, 9 1 and 10 1 are the 5 inverted pairs. That's the number of inversions. So write down 1 and then move on. So j is now at 6, I is at 0. So 2 compared with 4, that's not an inversion. So write down 2 and move I to the next index, which is 1. 3 compared with 4, no inversion. Write down 3 and move to the next index. Now 8 compared with 4, that's clearly an inversion. So the 3 inverted pairs are 8 4, 9 4 and 10 4, corresponding to mid minus I, 5 minus 2. Then move, so write down 4 and move j to the next index, so which is 7. Again 8 compared with 5, that's an inversion. So 8 5, 9 5, 10 5 are the 3 inverted pairs, mid minus I. Then write down the smaller element 7 and move j to the next index, 9. Now 8 compared with 8, that's not an inversion. 8 is not greater than 8, they are equal. So we cannot say that's an inversion. So we can decide which one to write down. So we'll follow a convention of writing down the element at the left side in the final sorted array. So that means we'll move the I to next index 3 and j is still at 9. So now compare 9 with 8. So see, that's how you break the tie. So if two values are the same, you copy the element on the left sorted subarray to the sorted array and move the index to the next index. So I is at 3, j is 9, 9 greater than 8. So that's an inversion. How many inverted pairs? 5 minus 3, 2 inverted pairs, 9 8 and 10 8. Then write down the smaller value 8 and then so we're done with the right subarray, so we copy the remaining contents of the left subarray 9 and 10 to this. So if you add up the number of inversions, you get the number of inversions in this particular merging step. So as I said, I could ask you something like this or give you the entire array itself and ask you to go through the process. So let us go through this example also, and with that we'll finish for today. So let us say you are given this array 2 8 1 9 3 7 and you want to go through the process of merge sort and also count the number of inversions. So you split it into two subarrays 2 8 1 and 9 3 7. So you see here this is a case of an odd size array of greater than 1. So you have 3 elements here. So if you look at the pseudocode of merge sort, how you split it. So we have n is 3 elements, right? So we split as from index 0 to n over 2 minus 1. So 3 over 2 is 1.5, but we take a floor. So it is 1.5 truncated is 1 and 1 minus 1 is 0. So that means only one element, which is at index 0, 0 to 0, is the element that gets copied to array B, subarray B. Then the other subarray is going to have from this, which is 3 over 2 truncated, which is 1, to 3 minus 1. So elements at index 1 and 2 are going to get copied to array C. So that's why I show here element at index 0 is in the left subarray and the elements at index 1 and 2 are in the right subarray. So they are 8 1. So now 2 is kind of sorted by itself. So when you merge it and anything, there's no inversion, it's just only one element, so 0 inversion. So then now you are splitting 8 1 into two subarrays 8 1 and they are now considered to be sorted. Now you are merging them. So we have to still keep track of the original index 0, 1, 2. So I'm writing down in red on top of the data the index values. So 1, the index is less than 2, so those are I and j. So mid is also 2 because that's the first index of the first element on the right subarray. So combining 8 and or merging 8 and 1, 8 is greater than 1, that's an inversion. And how many inversions? Just 1, because it is mid is 2 minus I, which is 1. So 2 minus 1 inversion. And that's that 1 inversion. And you are writing 1, 8, the merged array. So now we have to merge this subarray of just having 2 in it, and then this array 1, 8. So the merged array will be this, but how we get generated? So I is 0, j is 1, and the element at index I is greater than the element index j. So 2 greater than 1, that's an inversion. Is that the only inverted pair? Let us find out. Mid is always the index of the first element in the right subarray, which is 1, and I is 0. So 1 minus 0, it is just 1, so that's one inverted pair. So write down 1 here, and then move j to the next element, next index, which is 2. So now 2 compared with 8, 2 is not greater than 8, so there's no inversion. So write down the smaller value 2, and we don't have anything else to copy from the left side, so done with the left subarray. So copy the remaining stuff from the right subarray, which is just 8. So it's 1, 2, 8, that's the left sorted subarray. Now for 9, 3, 7, we'll similarly split it as 9 and 3, 7, and 9 is sorted already. 3, 7 split as 3, 7, and then now we are merging 3 and 7 at index 4 and 5. Now 3 is not greater than 7, so there's no inversion. So simply write down 3 and then write down 7. That's sorted. So now we are merging 9 with 3, 7. So your mid is 4, that's the index of the first element, the right subarray, and I is at 3. Now comparing the values at 9 and index 3 and index j, which is 4, 9 greater than 3, that's an inverted pair, 9, 3. Is that the only inverted pair at this case? For this case, yes, because mid is 4 minus I is 3, so there's only one inverted pair. Then write down 3 and move j to the next index, which is 5. So now compare the elements at index 3 and 5. You have 9 and 7, that's an inverted pair. So 9, 7 is now an inverted pair, and that's also only one inversion because still you have to use the mid minus I as the basis. That's 4 minus 3. So write down 7, and you're done with the right subarray. Write down the 9, the left subarray. So now let us merge these two sorted subarrays. So your I is at index 0, j is at index 3, which is also mid. Mid is the again the index of the first element in the right subarray. So compare 1 with 3. 1 is not greater than 3, so no inversion. So write down 1, move I to the next index 1. Now we have 2 and 3. Again, there's no inversion, 2 not greater than 3. So write down 2 and move I to the next index 2. So now you have 8 with 3. 8 is greater than 3. That's an inverted pair. Now is that the only inversion? Because yes, mid is 3 and I is 2. So 3 minus 2, mid minus I is 1. So 8, 3 is the only inverted pair at this point. So now write down the smaller of the two values, which is 3, to the sorted array, and then move j to the next index 4. So compare now at index I you have 8 with at index 4 we have 7. So 8 compared with 7, that's one inversion. Is that the only inversion at this point? Again, mid minus I will tell you that. So 3 minus 2 is 1. So 8, 7 is the only inverted pair based on that comparison. And then so write down 7 and then move j to the next index, which is 5. So compare 8 with 9. 8 is not greater than 9, so write down 8. And at this point we're done with the left subarray. Now write the remaining contents of the right subarray, which is 9, and that's the sorted array. Now if you count the total number of inversions, it will be sum of all these numbers. So there are 6 inversions, and what I have written inside parentheses are the inverted pairs, the 6 inverted pairs. Now you can always cross check for problem like this. This is the these are the inverted pairs you find using the merge sort algorithm, and you count the number of inversions. Now you can go through the brute force approach that I explained at the beginning of this topic. Just start with element at index 0 and see if anything to the right of it is less than it. So that's an inversion. So if you go through that approach, it's going to be 2, anything with less than 2 is 1. So 2, 1 is inverted pair. Similarly for 8, 8, 1, 8, 3, 8, 7 are inverted pairs. For 1, there are no inverted pairs. For 9, 9, 3, 9, 7. For 3, nothing to the right, it's less than 3. So that's the brute force approach. But as I said, you will do n square comparisons for that, whereas with the merge sort, you do n log n comparisons. Okay. So that will stop this video. So any